year. Before that, I was with Facebook AI for 3 years. Built a lot of the engineering teams for FAIR, Facebook AI research. What I will talk about is one of the most important aspects of scaling ML and AI within large organizations.
Please give a warm welcome to David. Thank you. You don't need it. All right. Hold on.
So before starting the company, I was doing a PhD at Princeton University, working in the economics lab. And the problem that we were solving is that we were taking a 1 millimeter volume of the mouse brain data, slicing 1/3 of the machine learning projects are failing because of having no solid data foundation. And this is a kind of a history. What happened is about while the databases or data storages have been developing. And we can see from Oracle days till now.
Please give a warm welcome to Timothy. Thank you.
We're going to do something a little different with this talk. I am not a data scientist. I am a data engineer. So it's going to be focused more on how do you get data to where it needs to go? How do you get models to where they need to go? How do you execute models in a stream, real time, as events happen, whether that's at the edge, whether that's wherever it may be. So this is a little different. Data is distributed around the world. You might be in different clouds. I may be capturing data on a device in a moving vehicle and need to get that to clouds around the world, different availability zones. We'll get it there. We don't crash. Everything is designed to be redundant, resilient, as much as you want. Again, this is open source.
I'm going to try to take us in a slightly different direction. Because at least my experience has been that the challenges of the technical sophistication, there's lots of ways to get around doing that.
And that encodes language information as sequential tasks. If we zoom out a little bit, you're going to be seeing a general trend of increasing generalizability.
To a subscription offering. So instead of just buying prom dresses and wedding guest dresses, we have everyday attire now, and we have people renting for based on a subscription model. So we have a number of structured attributes describing these. And some of these are defined by experts, like the buyers and the merchandisers who are bringing this inventory into the site. Some of them are defined by machine learning models. And
every one of them. I work for the R&D team that's embedded in the engineering org, and we build end-to-end data science solutions for the company. We ingest 2 million documents monthly at CBI. From data to use for information, it's actually the NLP work that we do at play.
For your listening, I'm Portion. I'm the head of Identity and Fraud Data Science team at Equifax. So today, I'm going to present something that we do in Equifax to capture synthetic ID fraud using a very, very unique machine learning approach leveraging graph mining. Synthetic ID fraud has been an uprising concern for several years. At the beginning, we just saw fraudsters stealing children's census, and they put fake ID around it, and then they pretend to be a real person, and they go ahead and steal money from the banks and business.
Perhaps one of the big challenges here is where do you get your training data for something like this? So the contemporary game playing algorithms, while they originally, so AlphaGo, the one that's popularized in the AlphaGo documentary, was trained on some human gameplay. But then the more recent versions of the game, there's no human gameplay that it's trained on at all. So you just have the algorithm playing against itself, and in so doing, it comes up with ways of learning and ways of playing Go that had world champion Go players describing it as like having aliens on Earth.
Game I recall depicts Europe right before World War I. Different empires, the Austro-Hungarian Empire, the Ottoman Empire. Now you would think the world has changed, and it has, but human nature has not. And it is in this context that it's now my pleasure to introduce Marius and Sherrard of Red Hat. They're going to discuss open source approaches to fostering collaboration on applying machine learning algorithms to address Worldwide challenges.
We are going to talk about machine learning for the greater good. I currently work at Red Hat. I'm the Director of AI Services with Engineering and Marius.
I also work for Red Hat. I'm a chief architect in the financial services team at Red Hat, focusing particularly on AI and how we help financial institutions use it. When they collaborate, for example, between competitors, why do they share data when there's a lot of concern around that? They try to protect data. That's their asset. The reality is that we have problems that go beyond computation. We have problems of general interest. How do you build models, for example, for risk management and taking account of climate, which is what we're going to see next. These types of problems are both requiring a lot of data, they require a lot of effort. So on the one hand, we want to eliminate duplication. On the other hand, there's no winner if someone gets it wrong.
When you talk about solving problems that require many entities coming together, a lot of times we hear companies coming to Red Hat because we have a history of collaborating in a transparent and open way. And a lot of times when you look at what Red Hat has done, it's providing a series of things that these open source collaborative communities need. The number one thing is governance. You get a group of people together, they don't always get along. So you have to define governing strategies, you have to put together steering committees. We've done this for a long time, so we provide a lot of value and a lot of insight to help communities do that. The other thing is how to collaborate. When you're talking about not just the code, but the data, all kinds of information, it has to be done, in a transparent way, and we provide some guidance there. And then ultimately, to me, the most important part of this is, as you're collaborating, who owns what? What does the licensing look like? If I'm developing new source code, or if I'm developing new data sets, then there has to be a level setting on what happens from a licensing perspective, how is that shared, what can you do with all of that information. And so that's kind of where Red Hat comes into the fold when we're talking about communities like OS Climate, which combats climate change, and when we talk about enterprise neurosystem. It's important to have that experience and that grounding so that everyone understands how to operate.
So my name is Matthew Dackermont, and I work at CVS Health about each. The analytic part is, like many of the company, we look from our different data sources coming from the business side I mentioned before, and we try to gain insights from this data.
Is there a risk officer, that's gonna check all the documentation, all the, privacy, like the fair lending is to check for privacy of the data elements. The risk officer needs to check for not just the documentation, but things like, did you do any analysis with the explainability of the model? Did you do any kind of, score, cutoff analysis, and see if there is any bias, for your whatever segments of customers, etc.